Hello and welcome back. Today I'll be starting a new series called PAT Walkthrough, where we'll walk through the 2011 PAT. This is Oxford University's physics admissions paper. So, let's get started. Part A is Mathematics for Physics, and we'll start with question 1. Question 1 asks us to find the values of theta between 0 and 2 pi, which solve sine theta minus 2 cosine theta equals -1. So firstly, we'll remember that cosine squared theta is equal to 1 minus sine squared theta, and therefore the equation that has been given transforms into sine theta minus 2 of 1 minus sine squared theta plus 1 equals 0. We therefore have 2 sine squared theta plus sine theta minus 1 equals 0, and this factorizes to 2 sine theta minus 1 and sine theta plus 1 equals 0. We therefore have sine theta equals -1 or sine theta equals 1/2. And solving these gives theta equals 3 pi over 2 or pi over 6 or 5 pi over 6. Now we'll move on to question 2. Here, we've been asked to sketch the function y equals 3 plus 2 sine of x minus 3 multiplied by pi over 3 between x equals 0 and x equals 12. Now we'll notice that this function can be obtained from sine x by 4 transformations. Firstly, we have to shift the entire function rightwards by 3. Then we squash it in the x direction by pi over 3, so that its period is now 6 and not 2 pi. We then amplify it by 2 in the y direction, and we shift the entire function up by 3. Plotting this, we should get something that looks like this as our function. Now let's move on. So, for question 3, the area A is defined as the area to the left of point X within an equilateral triangle with sides of length A. Find an expression for A as a function of X for 1. 0 less than or equal to x less than or equal to a over 2, and 2 for a over 2 less than or equal to x less than or equal to a. So firstly, we'll notice here that the height is simply root 3 of x, and therefore a is 1/2 of hx, which is root 3 over 2 of x squared. Now, in the second case, the area A is the area of the entire triangle minus the area of A, but for x as A minus x. This is equal to A over 2 times root 3 A over 2 minus root 3 over 2 of A minus x all squared. This simplifies down to 4 root 3 ax minus root 3 a squared minus 2 root 3 x squared all over 4. Now we'll move on to question 4. The figure below shows a rhombus with diagonals A and B, which contains a circle. Find an expression for the ratio of the area of the circle to the area of the rhombus in terms of A and B. So firstly, we'll notice that the area of the rhombus is AB over 2. Now, if we plot everything onto a coordinate graph, as on the right, we find that the gradient of the line AB is -b over a, and therefore the gradient of our radius that's marked over here is a over b. We therefore have a over b of x is equal to -b over a of x plus a over 2, and therefore x is equal to a squared b over 2a squared plus 2b squared. Substituting for y, we have a cubed over 2a squared plus 2b squared is y. Therefore, by Pythagoras' theorem, we have r squared equals a to the 10b squared over 4a to the 4 plus 8a squared b squared plus 4b to the 4. Then we have the area of the circle over the area of the rhombus is a to the 9b of pi all over 8a to the 4 plus 16a squared b squared plus 8b to the 4. Now, we'll move on to question 5. Given that log of 5 is 0.7 to 1 decimal place, find the value of x such that 2 to the x equals 10, again to 1 decimal place. We'll write log of 2 to the x is equal to log 10, and therefore x log 2 equals 1 by laws of logs. Now, log 2 can be written as log of 10 over 5, which is log 10 minus log 5. This is 1 minus log 5. And so the expression can be simplified to 0.3 of x equals 1, and therefore x is 3.3 to 1 decimal place. Finally, for the last question of this video, we have question 6. Evaluate the sum from 1 to 6 of 2 to the r plus 2r over 3. Now, I've chosen to do this by brute force because this is a fairly small sum. So, writing out all the terms and summing them up, we simply have that the expression is equal to 140. If you liked our video, please like and subscribe, and we'll see you next time for some more fun maths problems. Thanks for watching, and goodbye.